Let's talk about deleting nodes from the list. You'll have a function called remove, and you'll pass it a number that you want to delete. So the number will either be at the beginning of the list, in the middle of the list, at the end of the list, or not in the list. So you'll need to handle those 4 conditions. The remove function will return true if the node was deleted. Otherwise, if it's not in the list, it will return false. I will show you the algorithm for deleting the node in the middle of the list, and then I'd like you to draw it out and figure out how to do it if it's at the beginning of the list and at the end of the list. So let's say that we want to remove the node 7. So we'll hop into remove and we'll set a node, current node, to head, and we'll compare that data member. Is 1 equal to 7? No. So we'll set current node to current nodes next. So now current node is contains, and I'll just put a C right there to represent the current node. So now current node represents this node, and we'll do a compare. Is current node's data equal to 7? It is. So now we're ready to get rid of the node. We need to set current node's previous nodes next to point to current node's next node. And the syntax to do that would be we're going to set current node, its previous nodes next. So that's how we're going to get to this little location right there. We'll start here, right? We're going to go to previous node, and then we'll access the next pointer. So current node's previous next, we'll set that to current node's next. Okay, because current node's next is pointing to 5. So that's going to change this to point to that. And then we want to set current node's next node, its previous node, to point to current node's previous. So current node's next node's previous field will be pointing there. Okay, so we'll set current node's next node, its previous field, to point to current node's previous. Okay, because current node already has that pointer to previous, so we'll just set that way. And to access that syntax, you can say current node, its next previous, then we'll set that to current node's previous. And so we don't have any dangling pointers, right? Everything's being pointed to. We've updated 1's next. We've updated 5's previous. Head and tail did not need to be updated. We would only need to update those if we had deleted 1 or 5. And so we're ready to go ahead and delete current node. So the last step would be to just delete current node to free up that memory.